So today we're going to cover section 7. There's only one day of it. We're going to cover linear inequalities in one variable. So when we solve linear inequalities, we're going to use the same rules as when we solve an equation, except when we divide or multiply both sides of the equation by a negative number. When we do this, we're going to change the direction of the inequality sign. Our answers are going to be written as an inequality statement. We're going to be graphing them, and then we're going to be writing our answers in interval notation. So you probably did these. Okay, so again, what's new is going to be how we write our answers, the interval notation. So let's just review graphing on a number line, and what's new here is the interval notation. Now, what I'm going to do is I'm going to use the same number. I'm going to just put in a 4 here. Remember, you're reading this graph from left to right. So, for example, this first one, the first one is greater than, so x greater than any number. So I'll put in here x is greater than 4. When you graph a simple greater than or a less than, it's going to be an open circle. When it's going to be x is greater than or equal to, this will be a closed circle on the number line. Now, if you're graphing this, you're going to be doing it on WebAssign, but when you're doing it on a test, you can just put the number where you want to put the circle, and this would have been an open circle, and it's pointing to the right because it's all the numbers that are greater. If you need to see other numbers on either side, like I can put a 3 and a 5 on either side here. Same thing here. If you want to put the 3 and the 5 here, I just need to see the number where the circle is going. And again, when it's a greater than or less than, it's always an open circle. However, if it's a greater than or equal to, then it's going to be a closed circle. And then you point it in the direction. So greater than goes to the right, less than goes to the left. So here, x greater than or equal to 4. Here I'm going to graph x is less than or equal to 4, closed circle, pointing to the left. Now, what's going to be new here is we're going to be introducing negative infinity and positive infinity. So remember, the arrows on the ends of your number line tell us that this graph goes forever. So this is actually pointing to negative infinity over here and positive infinity. Maybe I'll do this in another color. So pointing to negative infinity, positive infinity, and you don't have to put the positive. So negative, positive, negative, positive. Now, what else is new here is the interval notation. So again, we're going to be adding in this infinity. So now instead of writing it, if it just asks you to write your answer as a simple inequality, you would just say x greater than 4. But if it asks you to write your answer in interval notation, whenever the symbol is a less than or a greater than, we're going to be putting parentheses around the numbers. When it's going to be a less than or equal to or a greater than or equal to, it's going to put brackets around the number. When we include infinity and negative infinity in our answer, these always get parentheses surrounding them. So let's go ahead and do the first one where it's x is greater than 4. In interval notation, again, think of it as reading your graph from left to right. So it's going to start at 4 and it goes to infinity. Infinity gets a parentheses. The 4, since it's just a simple greater than, also gets a parentheses. Over here, we come to negative infinity first, then we stop on the positive 4, and they're both parentheses. For the greater than or equal to, it'll be a bracket around the 4, and it points to infinity. Infinity and negative infinity always get a parentheses. For the less than or equal to, negative infinity is what I come to first, then the 4, negative infinity gets a parentheses, and because it's less than or equal to, the 4 gets a bracket. The next set is the compound inequalities. So what I'm having here, again, I'll add some numbers to this. So I'm going to say A here is going to be 2, and my B I'll say is 4. So this time, this is a compound inequality that's joined by the word and. So if I put least to greatest, put the 2 here, and then the 4, notice it's just simple less thans. So it's going to be an open circle, and joined in the middle. Now, what you can also think of this as is graphing these separately. So if you think about this one first, this is 2 less than x. When I used to teach this to my middle school students, I would tell them, think about this as being like a Pac-Man or an alligator, and I would always add little teeth to this. So if you wanted to switch this around, he's eating this, he's eating the x. So if you wanted to write and flip it around so that the variable's on the left, you can. And then you would also graph this one, x is less than 4. And then what you're going to be actually finally graphing is the overlap. So actually, let me do this one in red and this one in blue, and then the black will be what overlaps. So if I put the open circle on the 4, pointing this way, and then for this one in red, open circle on the 2, pointing this way, where you see both the red and the blue, that's the final answer, which is what I did in black. So you could write these separately and then also join them with the word and. So it could be x is greater than 2 and x is less than 4. Or write it with just the variable in the middle. Next one, it's going to be the same thing. The only difference is I'm going to change it into a bracket in my interval notation, and they'll be closed circles. Now, for this one, when it's the interval notation, we do not have infinity in it. It's just really the numbers that are between 2 and 4. So the interval notation for this one is 2, 4 in parentheses because it was just less thans. Over here, if I use the same numbers, 2 less than or equal to x, less than or equal to 4, put 2 and 4 on my number line. This time it'll be a closed circle. And again, if you want to graph them individually, this would be a closed circle on 2, pointing this way. And then, so that's for this part. And then for this part, this would be a closed circle on 4, pointing this way. And again, it's where you see both colors, which is the black. And again, interval notation, 2, 4, with brackets around them because it has the less than or equal to. When it's joined by the word or, these are going to be 2 rays pointing outward. So there's nothing in common. So let's go ahead and use the same numbers. So I'm going to use x less than 2 or x greater than 4. So add my 2 and my 4. So when I graph this one, it's an open circle on 2 going that way. This one will be an open circle on 4 pointing that way. And again, remember, these are pointing to negative infinity and infinity. So this time I'm going to use my set operators, the union and the intersection symbols. So what I'm going to do here is for the red, it goes from negative infinity to 2. Union, that's the gap here, with 4 going to positive infinity. Notice all parentheses. Next one, same thing, but I'm going to change it to brackets and closed circles. So x less than or equal to 2 or x greater than or equal to 4. So add the 2 and the 4. When I graph it, it's going to be a closed circle pointing to the left. And this will be a closed circle pointing to the right. In interval notation, again, it's going to go from negative infinity. I read left to right. So for the red, it's from negative infinity up to the 2. The 2 gets a bracket because of the less than or equal to. Then I union that with the blue. And it starts at 4 and it goes to positive infinity. Remember, infinities always get a parentheses around them. Now we're just going to solve the inequalities. And then we're also going to graph them and write our answers in interval notation. Again, we're going to solve these inequalities just like if this were an equal sign in between. But we got to remember to keep bringing that inequality symbol down. So I need to get my letters on one side and my numbers on the other. So I'm going to subtract 3x. Doesn't matter which way you move them. 2x minus 7 greater than 9. Move the 7 to the other side. 2x is greater than 16. Divide by 2. And x is greater than 8. Now, this is in just regular interval notation or regular inequality notation. This is probably how you did it in middle school and in Algebra 1. Now what we need to do is graph this answer and write our answer in interval notation. So if I go ahead and put in my number line, again, I don't need to fill it with the whole number line. All I need to do is put the number where my circle's going to go, and it's going to go on positive 8. And because it's just a greater than symbol, I'm going to put an open circle, and it's greater than, all numbers bigger than 8, so it points to the right. If you want to add in a 9 and a 7, just so you can see which side's smaller and which side's bigger, you can. Remember, this side is pointing to negative infinity. This one's pointing to infinity. And now we have to write it also in interval notation. So it's starting on the 8 with a parenthesis because it's just a greater than, and it's pointing to the infinity. Infinity always gets a parenthesis. Now, sometimes you're going to see this, instead of them putting opened and closed circles on the graph, they might also graph it with a parenthesis. So if it's a parenthesis in the interval notation, sometimes they'll put a parenthesis here and then point it. I'm not sure if that's what WebAssign is going to make you do. If it were a greater than or equal to, then you would put a bracket on the number line. So some standardized tests use circles, some use the same symbol that's in the interval notation on the number line. Let's try number 2. Again, I'm going to get my letters on one side and my numbers on the other. So I'm going to subtract 2x. I get 5x minus 3 less than or equal to 7. Add the 3. 5x is less than or equal to 10. Divide by 5. And x is less than or equal to 2. Remember, because it's less than or equal to, I'm going to be using a bracket and a closed circle on the number line. So put the 2 here. It's less than, so it's going to point to the left, closed circle. And again, remember, this is negative infinity it's pointing to. Over here is the positive. So in interval notation, when it's less than, it'll be pointing to negative infinity, comma the number, and because it was less than or equal to, the 2 gets a bracket. Number 3, I'm going to go ahead and clear the fraction. I'm going to clear the fraction so I don't have to deal with this. It's really not that bad. It's just 1.5, but I'm going to clear it. I'm going to multiply everything by 2 to clear the fraction. So this will become 2 minus 3x greater than or equal to 2x minus 8. And now I'm going to begin to solve. Now, let me just do this one, and because I've been moving the letters to the left every time, I'm going to go ahead and move it to the left, but then I'm going to show you what happens when we divide by a negative, how we have to reverse the symbol. Now, if you want to avoid having to remember to reverse the symbol, we can add 3 to the other side. It works. It doesn't matter which way you move it, but let me just show you how we would flip. And this is something you should have already learned how to do. I'm going to subtract 2x. I end up getting 2 minus 5x greater than or equal to negative 8. Subtract the 2. Negative 5x greater than or equal to negative 10. Now, this is where, when there is a letter or a negative number in front of your variable, and we're going to end up dividing or multiplying by a negative to solve, this symbol is going to flip around and go in the other direction. So I'm going to divide both sides by negative 5. And then I end up getting x, reverse the symbol because I divided by a negative, and then negative divided by a negative gives me positive 2. If you would have preferred to move the 3x to the other side, then you wouldn't have had to worry about reversing it. But whenever you multiply or divide by a negative, your inequality symbol will reverse. Now that I've solved it, I'm going to graph it. Negative infinity, positive infinity, put the 2 in the middle. It's less than or equal to, so it's going to be a closed circle on the 2, pointing to the left. Again, I'm going to write it also in interval notation. So as I read left to right, I'm hitting negative infinity first, and then I get to the 2, and I stop. Number 4, I'm going to do the same thing. I'm going to clear the fraction. I'm going to multiply everything by 3. So when I multiply everything by 3 here, this becomes 6 minus 5x greater than 3x minus 18. Remember, this 3 needs to distribute to all 4 pieces. And now, if you want to move the 3 over again, we would have to reverse. But just to show you, you can move the letters to the right. So I'll add. Your goal is to just get the letters on one side and then the numbers on the other. Then I'll add 18. 6 plus 18 is 24. Divide by 8. And I'm dividing by a positive, so nothing reverses. Now again, if you like to look at your letter on the left, again, remember, if you want to turn this into like a Pac-Man eating the 3, so when you turn this around, the X is here, and he still needs to keep eating the 3 that he was trying to chomp on. So then this would be the inequality notation here. And then again, I can graph it. Negative infinity, positive infinity with the 3 in the middle. Again, I'm going to have an open circle, and it's less than, so pointing to the left. And then an interval notation, negative infinity to the 3 with parentheses around both. Next, we'll do the compound inequalities. For the next part, I like to work with it as it is. If you prefer, you can also pull this thing apart. So what I could do is say that it's 5x minus 2, and then write an inequality for this one. Join it with the word and then 5x minus 2 less than 7, and then solve the 2 problems individually. But I'm going to work with it as it is. It's a lot easier. So what I'm going to do here, instead of just having to add the same number to the left and the right, I got 3 parts. I've got the left that I'm going to have to add a number to, the middle or the center, and then the right. So when I go to start to move my stuff away from x, that's my goal, is to get this x that's next to the 5 all by itself. So what I'm going to be doing here is adding 2, but I need to add it to the left, the middle, and the right. And then I'm left with negative 2 less than or equal to 5x, which is less than 9. And now I'll divide everything by 5. My goal is to get x all by itself. So my answer here is negative 2/5 less than or equal to x less than 9/5. Now I need to graph it and write it in interval notation. Whenever it's like this and it's the compound with an x in the middle and then numbers on the either side, all you have to do is look at the symbol, so negative 2/5, and you have to write at least to greatest. So negative 2/5, comma 9/5. Since it's a less than or equal to, it gets a bracket. And since this one has a less than in front of it, it's a parentheses. So over here, graph it, least to greatest. So negative 2/5 first, 9/5 second. Remember, this is negative infinity, positive infinity. But again, this is just going to be a segment, closed here, open here. Yes? I'm going to do the same thing here. Treat it to all 3 parts. So I'm going to add 1 to the left, center, and right. I get negative 2 less than or equal to 6x, which is less than 4. Now I divide everything by 6. And I get negative 2/6 less than or equal to x less than or equal to 4/6. I need to reduce these fractions. 2/6 will simplify to negative 1/3. 4/6 will simplify to 2/3. In interval notation, again, it's got different symbols. So the negative 1/3 gets the bracket because it's the less than or equal to, and the 2/3 gets the parentheses because it's just the simple less than. And again, graph it. Least to greatest, so negative 1/3, 2/3, and again, the circles, this will be a closed up to an open. And again, remember, negative infinity is here and infinity is here. Let me do numbers 7 and 8 here. So again, when it's the compound, we have to do the same thing to all 3 pieces. So subtract 7 from the left, the middle, and the right. Negative 6 less than or equal to 2x, which is less than 4. Divide everything by 2. Negative 3 less than or equal to x, which is less than 2. So again, when I graph it, negative infinity's here, positive here, negative 3, 2. So the negative 3 gets the closed circle, the positive 2 gets the open circle, and it's a segment joining them in between. So actually, I changed this. This should not be an or equal to. The original symbol was a less than, and I got to keep the same symbol. So open on both ends. And again, the interval notation, negative 3, comma 2, with parentheses because they were both just a less than. And then number 8, again, just like before, I'm going to clear the fraction. So I'm going to multiply everything by a 3. So this becomes negative 12 less than or equal to 2 minus 3x less than 15. So again, do the same thing to all 3 pieces. So I subtract 2. Negative 14 less than or equal to negative 3x, which is less than 13. Again, when I divide by a negative, dividing everything by negative 3, I'm going to reverse both symbols. So this becomes negative divided by a negative is positive, reverse, reverse, and then negative 13/3. I now can graph this, and again, I want to write it from least to greatest. So negative 13/3, and again, remember, to reverse the symbol because Mr. Alligator was eating the X. So we're flipping these both around. And again, add in your numbers. Negative infinity, positive infinity. It's going to, again, be a segment joined in the middle. So this is open circle, closed circle, and then in interval notation, negative 13 over 3 with a parentheses, 14 over 3 with a bracket. And that is it for the inequalities. And now on to absolute value. Okay, so solving absolute value inequalities, just like before with the equations, first step is to isolate the absolute value. Then, if the absolute value becomes a less than or equal to, it becomes an and statement. If the absolute value is greater than or equal to, then it becomes an or statement. So, what I would always tell my class, my Algebra 1 class, I would tell them, I sort of like exaggerate the words. So this symbol and this symbol is the less, and I tell them less than, so it gets an and. This is a greater, but I change it, and instead of ER at the end, I say it's greater. So whenever it's a greater than or equal to, greater, it's an or, but when it's a less than or equal to, then it's an and. You're going to see what I mean by that. Because remember, for the absolute values, we got to make the two problems. So again, we're going to isolate first. So my absolute value symbol is isolated. So now I'm going to make my two problems. Remember, yesterday, when we did the equations, we would make one positive and one negative. So I dropped the bars for the first one. But for the second one, I drop the bars, flip the symbol, and make the answer negative. And because this original symbol was a less than, we're going to join these two with the word and. So I'm going to solve each one individually, and then the word and will go in between. So add 5. X is less than 7, and now I'll solve this one. X is greater than, and this should be a 5. X is greater than 3. So these are my two answers. Now, whenever it's an and, you can also join them and just write them as a single compound inequality. Put the numbers least to greatest. Put the X in the middle. And you see how Mr. Alligator on the 3 is eating the X, and on the 7, it's eating the 7. So just make sure they face the same way. And now we would graph this as well. So here and here, 3 and 7. Negative infinity, infinity, and open circles, and joined in the middle. And again, in interval notation, remember you just write it as 3, 7 when it's that segment. And again, it's parentheses because it was just a simple less than. Yes?
Wait, won't you change the signs again?
You change the signs whenever you divide by negative or multiply, but in this, when you make your two problems and you make the second one, you got to flip the sign and make it negative. Let's try the next one. It's already isolated. Notice my symbol is a greater than and then equal to. So this is going to be an or because it's greater. So now I make my two problems. Drop the bars. Or drop the bars and flip it and make it negative. And that should be a 3. And now I solve both of these, but I'm joining them with the word or. When it's joined with the word or, I can't make it into the simple single inequality. I just have to keep them separately joined with the word or. So I'm going to subtract 3. X is greater than or equal to 4. Or, And then solve this one. X is less than or equal to negative 10. So again, we need to put them in least to greatest. So when we go to put this on our number line, it would be like this. So add it to the number line. This is where we're going to use our union. So negative 10 here, positive 4 here. So when I graph this one will be in a closed circle going that way, closed circle going that way. And then to write this in interval notation, it goes from negative infinity up to the negative 10. It's got this little gap here, so I put a U there for the gap. And actually the 10, it gets a bracket. So this negative 10 gets a bracket because it was less than or equal to. The 4 gets a bracket as well. And going to infinity. So number 11, same thing, isolate first. This is a less than, so I'm going to make it an and. So drop the bars, just write it as it is, join it with the word and, x minus 20, flip it and make it negative. Add the 20. X is less than or equal to 24 and add the 20. X is greater than or equal to 16. So again, I want to write at least to greatest, so let me flip this around. So I can flip that around, or I can also write it compoundly, 16. And then again, it's eating the X, eating the 24. Graph it, negative infinity, 16, 24. And again, these are got a or equal to, so they're closed circles, joined in the middle. And then the interval notation is just 16 comma 24 with brackets around both numbers. Next one, remember, isolate first. So I need to divide both sides by negative 3. I don't want to distribute that. Okay, remember, when you divide by negative, this symbol's going to reverse. You don't look at it until you've isolated to figure out the word. So now this is a less and, so it's an and again. So again, drop the bars, write the word and, drop the bars, flip it, make it negative. Solve each one. X is less than or equal to 6. And X is greater than or equal to negative 4. Again, I'll flip it around. If we want to just go right into our compound, it would look like that. On the number line, negative 4, positive 6. And then these are closed circles, joined in the middle. The interval notation, negative 4, comma 6, with brackets. On the next slide, they're going to be special cases. Whenever we see a negative number, that the absolute value is less than or equal to, or greater than or equal to, or if it's a 0, special things are going to happen. So the last 4 special cases. So for the first one, I need to isolate first. Negative 2, x minus 1, and I divide it by a negative, so I reverse. And now, yesterday when we saw this, if this were an equal sign, it would be no solution, because we know we can never get a negative out of here. However, now it's an inequality. We're always going to get a positive, so this answer, we don't need to do the 2 cases. The answer is just all real numbers, because what's going to come out of that absolute value will always be positive. So this is all real numbers. All right, So this is all real numbers. The way that we will write all real numbers in interval notation is we will show it goes from negative infinity to positive infinity, because technically this is the entire number line. So it would be everything here. And that would be all real numbers. Another symbol that you may see later on for all real numbers, it's like a capital R, and then they add another stick there. The next one, also another special case. Whenever you see that your absolute value is got a 0 over there, that it's going to be less than or equal to, or greater than or equal to, or less than or greater than, and it's a 0 or a negative number, you need to stop and pause and think about it. So for this one, we already know that what's going to come out of this will never be negative. However, we can solve this for the or equal to part. So nothing is going to happen. This will never, ever give me a number less than 0, so I don't solve that part of it. What I'm going to solve is the x minus 1 equals 0, and x is equal to 1. That will be the only thing that would be the answer to this absolute value. So again, you could put a 1 here, and it would just be that single dot. And then for number 15, this time the symbol, again, it can never be less than 0 again. However, it could be equal to. So it would never be less than 0 because it can never be negative. However, it could be equal to 0, and that's what we're going to solve for. So here we would write 2x minus 1 equals 0, add 1, 2x equals 1, divide by 2, and x equals 1/2. And again, graphed, it's just a single closed circle on the 1/2. For number 16, for this one, what we have to figure out is what it can't be. So it's always going to be positive, except for it can't equal 0. So this is what it can't be. It cannot be equal to 0. So I'm going to solve this, and this is going to be like a hole in my graph. So I'm going to add 1. 2x cannot equal 1, divide by 2. So it's going to be all real numbers except when x equals -1/2. So the answer here is all real numbers except when x equals 1/2. So on my number line, we have negative infinity to positive infinity. And I'm going to put the 1/2 here. So it can't be this. So I'm going to make a little open here. But then it's everything else. And the way that we're going to write this in interval notation, it's going to go from negative infinity with a parenthesis up to the 1/2 with a parenthesis. The whole is I'm going to put there as a union. And then it starts up again as it jumps off of the hole. And then it goes to infinity. And that would be your interval notation for this example. Let me just show you one more that, again, is not in the notes. So, for example, if I gave you the problem 4x minus 7 in absolute value, and it's less than a negative number, know that we will never, ever get something that's less than a negative number out of this one. So it would be no solution. On a number line, you would just leave it empty. So that is a no solution answer whenever you have something that's less than or even less than or equal to. Okay, so just remember, we can never get something that will equal a negative number or be less than a negative number. So that is it for section 1.7.